Hi there, thanks for joining us today. I've had a chance to look over your resume, and it looks like you've got a solid foundation with about 3 years of experience in the Angular ecosystem. We're looking for someone who can take ownership of features and really understand the moving parts of the framework. To get us started, I'd like to keep things simple. Could you walk me through how you'd actually declare a basic component in Angular? Just the fundamentals of how it's put together.
Sure thing. To declare a basic component, I start by creating a class and then decorating it with the component decorator. That decorator is really the key because it tells Angular that this isn't just a regular TypeScript class, but a component. Inside that decorator, I provide the essential metadata. First, there's the CSS selector, which defines the custom HTML tag I'll use to display the component in other templates. Then I have the template, which is where the actual HTML content lives that gets rendered on the screen. Usually, I'll also specify a style property to link my CSS. Finally, I have to make sure the component is registered. Depending on the version and architecture, that means either adding it to the declarations array of an ng module or, in more recent versions, marking it as a standalone component so the application knows it exists and can instantiate it.
That's a good, clear summary. Now, moving from the basics, let's talk about how we actually interact with the DOM or other components. I'm interested in your experience with ViewChild and ViewChildren. Could you describe the lifecycle and internal workings of those, and maybe include ViewContainerRef in that explanation? Specifically, when would you actually find it necessary to use these for manual manipulation?
Right. So, ViewChild and ViewChildren are decorators we use to get a reference to a component, a directive, or a specific DOM element inside a template. The main difference is that ViewChild grabs the first matching element it finds, while ViewChildren returns an observable list of all matching elements. One thing that's really important to remember is the lifecycle timing. These references aren't available immediately in ng on init. They only become available during the after viewInit hook. That's because Angular has to actually render the template, and the child views before it can find those elements. Now, ViewContainerRef is a bit different. While ViewChild gives you a reference to an element, ViewContainerRef is more like a placeholder or a container in the DOM where you can programmatically inject components. Internally, if ViewChild gives you a reference to a component, that component usually comes with its own ViewContainerRef, which allows you to move, add, or remove other components around it. As for a scenario where this is necessary, a great example would be building a dynamic modal system or a toast notification manager. If I need to inject a component into the DOM based on a user action, like a pop-up that doesn't have a fixed place in the HTML, I would use ViewContainerRef to dynamically create the component and attach it to a specific spot in the UI. It's essentially the only way to handle truly dynamic component injection.
That makes sense. Speaking of dynamic components and updates, let's dive into performance. When you're dealing with a complex app, you often run into unnecessary rendering cycles. If you were tasked with debugging a performance issue related to change detection, what specific tools or methods would you use to pinpoint exactly which part of the component tree is causing the lag?
Performance tuning is always an interesting challenge. My first stop is usually the Angular DevTools browser extension. Specifically, I'll use the Profiler tab. It's incredibly helpful because it visually highlights which components are re-rendering and exactly how long each cycle takes. If I see a huge chunk of the tree flashing green or red during a small interaction, I know I've found the culprit. If the issue is more subtle, I might use the ng zone, on stable promise, or even a custom zone-based logger to track exactly when the change detection cycle starts and ends. For a more granular approach, I'll implement the ng on changes lifecycle hook, or just a simple setter on a component's input property. By logging every time an input changes, I can determine if a parent component is triggering a cycle without actually changing the underlying data. And if I suspect a global service is the trigger, I'll check for things like async pipes or manual Mark IV check calls. I also like to use the Chrome Performance tab to capture a flame graph. That allows me to see if a specific function is being called repeatedly during the digest cycle, which helps me differentiate between a logic bottleneck and a framework-level rendering issue.
You mentioned manual Mark IV check. That leads me to a related question. In your experience, what are the potential pitfalls when a developer starts manually triggering change detection, like using detect changes? Why is that generally discouraged in a healthy code base?
Manually triggering change detection, especially using change decorator detect changes, is a bit of a slippery slope. The biggest danger is accidentally creating an infinite loop. If you call detect changes inside a lifecycle hook or a function that modifies a property, that modification can trigger another change detection cycle, which calls the function again, and eventually, the browser just crashes. Beyond the loops, it bypasses Angular's optimized rendering strategy. By forcing a manual check, you're often forcing the framework to check the entire component tree, even if only one tiny piece of data changed. This leads to sluggish interfaces and dropped frames, which kills the user experience. Then there's the dreaded expression chain after it has been checked error. This happens when a value is changed, after Angular has already finished verifying the view for that cycle. If you're manually forcing detection at the wrong time, you'll see this error constantly. It basically means the data and the UI are out of sync, and it usually indicates a deeper architectural problem with how data is flowing through the app.
Definitely a common pain point. Let's pivot to architecture. Imagine you've inherited an application that's grown quite large, and it's using a lot of isolated services to manage state. It's becoming hard to track where data is coming from. How would you approach refactoring that into a centralized store, like NGRX or NGXS?
That's a classic scaling problem. My approach would be to do it incrementally rather than a big bang rewrite, which would be too risky. First, I'd identify all the shared pieces of data and the logic used to update them across the app. Instead of having services hold internal variables and trigger manual updates via subjects, I'd move that data into a single source of truth, the state. I would replace the direct method calls in the services with actions. Actions are just simple messages that describe what happened, like user logged in or cart updated. Then I'd implement reducers. A reducer is a pure function that takes the current state and the action and calculates the new state. This makes the state transitions predictable and easy to debug. To get that data back into the components, I'd use selectors. Selectors are basically filtered queries that give the component only the specific slice of state it needs. This prevents components from re-rendering every time any part of the global state changes. To keep the app running during the transition, I'd keep the existing services as a thin wrapper. The components would still call the service, but the service would now just dispatch an action to the store. This way, I don't have to rewrite every single component immediately, and I can migrate one feature at a time.
I like the incremental approach. Now let's talk about routing. Suppose you need a custom routing guard to check authentication status and redirect unauthorized users. How would you implement that? And how would you handle the interaction between the guard and the resolve states?
To implement this, I'd create a class that implements the CanActivate interface. Inside this guard, I'd inject my authentication service to check if a valid session or token exists. If the user is authenticated, the guard simply returns true and the root transition proceeds. If not, I'd use the router service to redirect them to the login page. The part about resolve states is crucial. In the root configuration, the guard must be placed before the resolver. Angular processes guards before it even attempts to run the resolvers. This is important because we don't want the application wasting resources and making API calls to fetch data via a resolver for a user who isn't even authorized to see the page. For more complex or asynchronous checks, like if the guard needs to verify a token with a server, the guard can return an observable or a promise. This ensures the router waits for the authentication check to complete before it moves on to the resolution phase.
Let's shift gears to RxJS. It's a huge part of Angular. One of the most common patterns is the async pipe. For someone who might be new to it, how would you explain what problem the async pipe actually solves?
The async pipe solves the problem of manual subscription management. In a typical scenario, if you subscribe to an observable in your TypeScript file, you have to store that subscription in a variable. Then you have to remember to call unsubscribe in the ng on destroy lifecycle hook. If you forget, that subscription stays active even after the component is gone, which leads to memory leaks and potentially logic running in the background that should have stopped. The async pipe automates this entire lifecycle. When you use it in the HTML template, it handles the subscription the moment the component loads, and more importantly, it automatically unsubscribes when the component is removed from the DOM. This makes the code much cleaner because you don't need as much boilerplate in your TypeScript file, and it guarantees that you won't have memory leaks from that specific stream.
Speaking of subscriptions and memory leaks, what happens when you're dealing with long-lived observables where the async pipe might not be an option? How do you handle those in the TypeScript code to ensure the app stays performant?
When I can't use the async pipe, maybe because I need to perform some logic on the data before it hits the view, I have a few strategies. The simplest is the manual unsubscribe in ng on destroy, but that gets tedious if you have 10 different subscriptions. A much more scalable approach I prefer is using the take-until operator. I create a private subject, usually called destroy $, and I set it to emit a value in the ng on destroy hook. I then pipe take until this destroy $, into all my observables. This tells the observable to automatically complete as soon as the destroy subject emits, which effectively cleans up all subscriptions at once. It's really all about ensuring that no matter how the component is destroyed, the stream is closed. If you're working with a shared service that emits values globally, failing to do this can lead to a scenario where the same function is being called multiple times for the same logical event, which is a nightmare to debug.
That's a solid approach. Now let's talk about handling data. Imagine a scenario where you're fetching data that depends on multiple independent API calls. You need all of them to finish before you can process the final combined result. How would you handle that using RxJS?
For that specific scenario, I'd use the fork join operator. Fork join is very similar to promise all in standard JavaScript. It takes an array or an object of observables and waits until every single one of them completes. Once they've all emitted their final values, fork join emits a single array or object containing those results in the same order they were provided. It's perfect for independent calls. However, there is one major pitfall. If any one of the API calls fails, the entire fork join fails. To prevent a single failed request from breaking the whole page, I'd handle the errors for individual calls. I'd use a catch error operator on each internal observable to return a null value or a default object. That way, fork join still completes, and I can handle the missing data gracefully in the component.
Good point on the error handling. Let's move back to the UI and input. What do you consider the simplest way to handle user input from an input field in an Angular template? I'm not necessarily looking for a full-blown form, just the quickest way to get a value.
The simplest way is by using template reference variables. You can just add a hash symbol and a name to your input field, like username. Then you can access the value of that input directly in the template or pass it as an argument to a function in your component using the variable name, like username value. This completely bypasses the need for data binding or complex form setups when you just need a quick value for a search bar or a simple trigger.
Now, let's talk about a more robust way to handle inputs. When would you choose reactive forms over template-driven forms? And what exactly makes them a better choice for complex logic?
I almost always reach for reactive forms when the project is more than a simple prototype. The main difference is that reactive forms are model-driven. Instead of the logic being scattered in the HTML template, the entire form state is managed in the TypeScript class using form control, form group, and form array. This provides a few massive advantages. First, scalability. Since the form structure is defined in code, it's much easier to add or remove fields dynamically. Second, unit testing is significantly easier. You can test the validation logic and the value changes in the TypeScript class without having to render the DOM or simulate clicks. Third, the control over validation is much more precise. You can add custom validators or change validation rules on the fly. And because the form state is essentially an observable stream, I can use RxJS operators to react to every single keystroke in real time, which is something that's very clunky to do with. Template-driven forms.
Let's discuss component communication. You have a lot of options here. When should you use an output decorator versus when you should move that logic into a dedicated service?
I follow a pretty simple rule of thumb. If it's a direct parent-child relationship, at output is the way to go. If a child component needs to notify its parent that a button was clicked or a form was submitted, an event emitter with at output is clean, explicit, and keeps the components decoupled. However, as soon as the communication gets more complex, like between two sibling components or components in entirely different branches of the application, at output becomes a nightmare because you'd have to bubble the event up through multiple layers of parents. In those cases, a dedicated service is a must. Services are also superior when you need a single source of truth. If multiple components need to share and synchronize the same piece of data in real time, a service allows them all to subscribe to the same stream. This avoids the prop drilling problem and ensures that when the data updates in one place, every observing component updates instantly.
That's a very practical way to look at it. Let's touch on a few more core concepts. Could you explain the concept of an ng module and the purpose of the ng module decorator?
An ng module is essentially a way to organize an Angular app into conceptual blocks. I think of it as a container that tells Angular which components, directives, and pipes belong together. It's all about dependency management. By specifying which other modules are needed and which components should be exported, you can create a modular system where features are isolated. The ng module decorator is what actually defines these modules. It provides the metadata, the declarations for components the imports for other modules, and the providers for services. This organization is what enables features like lazy loading. Instead of loading the entire app at once, you can tell Angular to only load a specific ng module when the user navigates to a certain route, which drastically improves the initial load time of the application.
Just a quick check on the basics of data binding. What's the difference between using double curly braces for interpolation and using square brackets for property binding?
Interpolation, the double curly braces, is primarily for rendering text. It takes a value from TypeScript, converts it to a string, and puts it inside the HTML. It's great for things like labels or displaying a username. Property binding, the square brackets, is for passing a value directly into an element's property. The big difference is that property binding doesn't just convert everything to a string. It allows you to pass complex types, like booleans or objects, directly into a property. For example, if I want to disable a button based on a boolean in my code, I'd use disabled equals is pending. You can't really do that with interpolation.
And along those same lines, how does ng-model differ from standard property binding?
Property binding is a one-way street. Data flows from the TypeScript class to the HTML element. If the user changes the value in the input field, the variable in the code doesn't change automatically. ng-model, specifically when used with the square and round brackets together, is two-way data binding. It creates a synchronization loop. If the variable in the TypeScript code changes, the input field updates. If the user types into the input field, the variable in the code updates immediately. It's basically a shorthand for combining property binding and event binding.
I want to move into some deeper territory. Many developers coming from React are used to the virtual DOM. Angular doesn't use a virtual DOM. Can you explain how Angular's change detection approach differs from the virtual DOM strategy?
Yeah, this is a fundamental difference. The virtual DOM, which React uses, creates a lightweight copy of the entire DOM in memory. When data changes, it builds a new virtual tree, compares it to the old one to find the exact differences, a process called diffing, and then applies only those changes to the real DOM. Angular takes a different path. Instead of comparing two trees, Angular uses a process of tracking changes. It attaches listeners to data-bound properties. When an event occurs, like a click or an HTTP response, Angular triggers a change detection cycle that flows from the top of the component tree down to the bottom. It compares the current value of each variable with its previous value. If they are different, it updates that specific DOM element directly. So, while the virtual DOM focuses on comparing two snapshots of the UI, Angular focuses on tracking the data changes and updating the view as a direct result of those changes.
Let's talk about state management again, specifically the tools within RxJS. How do you use a behavior subject, and why would you choose that over a standard subject?
A behavior subject is a special type of subject that stores the current value. The biggest difference is that a standard subject doesn't have a memory. If a component subscribes to a subject after a value has been emitted, it just misses that value and waits for the next one. A behavior subject, however, requires an initial value when it's created, and it always emits the most recent value to any new subscriber immediately upon subscription. This makes it perfect for state management. For example, if I have a user's authentication status, I want any component that loads, regardless of when it enters the DOM, to immediately know if the user is logged in or not. With a behavior subject, the component gets the current status the moment it subscribes, without having to wait for a new login event to happen.
Last technical question before we wrap up. If you're using the Angular CLI and you need to spin up a new component, what's the process? And what does that command actually do behind the scenes?
To create a new component, I use the command generate component, followed by the name, like ng generate component user profile. Behind the scenes, the CLI does a lot of the heavy lifting. It doesn't just create one file, it automatically generates four: the TypeScript class for the logic, the HTML file for the structure, a CSS or SCSS file for the styling, and a spec file for unit testing. More importantly, it automatically adds the component to the declarations array of the nearest ng module. This saves me from having to manually register the component, which reduces the chance of forgetting to do it and running into component not found errors.
Great. I think that covers all the technical ground I wanted to explore. You've shown a really good understanding of both the how and the why behind your architectural choices, and that's exactly what we're looking for in a mid-level dev. Do you have any final questions for me about the team or the role?
I'm curious about the current state of your codebase. Are you mostly using standalone components now, or are you still heavily reliant on ng modules? And also, how does the team handle code reviews for complex RxJS pipelines? I've found that those can be a point of contention if there isn't a shared standard.
Those are fair questions. We're actually in the middle of a migration to standalone components for all new features, so you'd be coming in right as we're shifting that paradigm. As for RxJS, we actually have a shared style guide, and we use a lot of pairing for the more complex streams to ensure they're readable. We'll definitely dive deeper into that if we move forward. Thanks for your time today. It was a pleasure talking with you.
Thank you. I appreciate the conversation and look forward to hearing from you.